This video will explore what happens when two forces perpendicular to each other are applied on the same object. So let's just imagine when I grab one of these arrows, they represent a force. They are vectors, and we know that vectors have a magnitude and a direction. So let's just say this vector that I've grabbed will represent the force that you will be exerting on that shopping cart. Now remember, I said it was going to be 20 newtons, so I'm going to extend this vector until it's, notice the magnitude of it up here is 20 newtons. So let's imagine this is you exerting that force on the cart. Now let's imagine someone else exerting the same magnitude force, 20 newtons, but perpendicular to you. So I'm going to turn it like that and extend it until the size of this vector is 20 newtons. There we go. So they're both. So let's imagine that the shopping cart is right here at the head of both vectors, and we want to know what will happen to it. Which direction will it go in, and what is the force that's being applied to that shopping cart. So I'm going to hit show sum, and you're going to see a vector that represents the resulting vector with a certain magnitude and direction. And there it is. So you can see that it's actually going at a diagonal to those two, which kind of makes sense if you try to visualize two people pushing perpendicular to each other. The object will end up going in a diagonal direction. And notice the magnitude of the vector. It's a little greater than each individual vector, but not as big as the sum of the two put together. So these two vectors are the decomposition of this one vector. They make up this one vector. And that's what we're going to explore in a little bit more depth. When you look at one vector, how do you decompose it in its two perpendicular or rectangular components?